All right, in 8.2, we are talking about line graphs. Again, continuing our unit on different types of graphs and plots. So a line graph is used to show how values change. A line graph is useful for displaying data or information that changes continuously over time. The points on the line graph are connected by a line. Another name for a line graph is a line chart. So if you remember bar graphs, we were splitting things into categories. A line graph is we're going to look at how things change over time. Again, the notes are very detailed, so feel free to read through those. I'm just going to hit some highlights. We're actually going to look at some different line graphs and then look at how to interpret them, and then actually look at making our own. So it says, example one, the table below shows daily temperatures for New York City recorded for 6 days in degrees Fahrenheit. Again, we said that a line graph is going to look at values changing over time. So this is temperatures changing over days. So if you look at that table and then come down and look at the line graph, the title of the table is temperatures in New York, so that becomes the title of our graph. On the horizontal axis, we have the days, 1 through 6. And then on the vertical axis, we have the degrees in Fahrenheit in 20-degree increments. If you look, our highest degree is 67, so they had to make sure that it went high enough to cover that. And then as you look, these dots on the line graph are just showing how the temperature changes over time. Next example is the value of Sarah's car. In case you didn't know, a car loses value basically as soon as you start driving it. So again, it's something changing over time. This time it's dollars over changing through the years. So if you look, we have a title for our graph, the value of Sarah's car. We've got the years on the horizontal axis. We've got the value in dollars on the y-axis. And then our plots are pointed. As you look, it's a pretty steady decrease as we go through the years. Then example 3 says Sam's weight in kilograms for 5 months. So the months are listed, the weight in kilograms is listed. So when you come down to your line graph, Sam's weight is the title, we've got the weight on the y-axis, and we've got the time in months on the horizontal axis. So the months we're going through and the weight on the left. And as you can see, Sam's weight increased throughout the months. So in example 1, the temperature changed from day to day. Example 2, the value of Sarah's car decreased from year to year. And example 3, Sam's weight increased each month. So all of our line graphs show a change in data over time. That's what a line graph is going to show you. So it's just a graph we use to help us define the parts of a line graph. So we already talked about this a little bit. But we've got a title that just lets us know what the graph is all about. The labels, so the horizontal label right here, vertical label right here. The horizontal label is usually going to be your time, like as we saw in examples of days, the years, the months. And then the vertical label is usually going to be whatever you're measuring that in, dollars, kilograms, whatever the case may be. The scales, the horizontal scale across the bottom and the vertical scale along the side tell us how much or how many. Okay, again, if you remember, our horizontal label had words sometimes, doesn't always have to be numbers. The vertical ones are pretty much always going to be numbers. And the points are the dots on the graph that shows the facts. So like, for example, in January he weighed this much, in March he weighed this much, so those are our facts. And the lines just let us kind of estimate what's going on between those dots. So it says, let's answer some questions now based off of a line graph. So if you go ahead and fill this out as we go along. So the first question says, what is the title of the graph? So for us, that title for this one's going to be the temperatures in New York City. As you can see, it's just right here across the top. That's going to be our title. The next question says, what is the range of values on the horizontal scale? Again, horizontal is going to be this one, left to right. So the range is just the biggest one minus the smallest one. So our biggest one is 6. Our lowest one is 1. So our range is going to be 5. Next question is, what is the range on the vertical scale? So if you look at our vertical scale, which is up and down, our highest value on the scale is 80, and our lowest value on our scale is 0. So that means the range is 80 on that vertical scale. Next question is, how many points are on the graph? So our points are just all, each one of these, 43, 53, 50, etc. So we have 1, 2, 3, 4, 5, 6 points on our graph. It says what was the lowest temperature recorded, so that's just going to be our lowest dot, which was 43. What was the highest temperature recorded, so our highest dot, which was 67. And then it says at what point did the temperature dip? So if you look up at our graph, a dip in temperature is going to be a decrease. So if you look, the only decrease is right here. It dropped from 53 to 50. So that was from day 2 to 3. So that was the only time we saw a dip in the temperature. So next we're going to look at constructing our own line graph. So let's look at our first example. Example 1 says the table below shows Jill's math scores in secondary school. Construct a line graph to visually display this data. So if you look, we've got grade level 7 through 12, and we have our math score for each one. So the first step is to find the range in values. It says there are 2 sets of values, what units are used. So one set is grade levels, the other is percentages for math scores. And then we'll look at the greatest and least value for the first set. So let's say for our grade level set, the lowest is 7, the highest is 12. And then for the scores, our highest score is 91, our lowest score is 72. So we need to determine a scale. So start with the horizontal scale. If you're using graph paper, let 1 unit on the graph paper equal 1 unit of the values. Determine whether the greatest will fit on the graph. If it doesn't change the scale, then repeat for the vertical scale. So before you actually plot anything, you need to get your scales down and make sure you can fit your highest values. It says the vertical scale must start at 0. So our vertical scale is going to go from 0 to 100 because she went all the way up into the 90s for some of her grades. If you look at our horizontal scale, it's just going to go from 7 to 12 for the different grade levels. Then it says label the graph. It says mark each unit across the horizontal scale, and along the vertical scale, label the marks by the units they represent. So if you look our horizontal on grade level 7 through 12, our math scores, we went from 0 to 100 and we went by 20s. So the next thing we're going to do is plot the points and connect them. So we're just going to match up the grade level with the math score that they had. And that's how we'll get our points on there. After we get all of our points on there, we can actually just connect all those points together until we've got a line graph all the way across. And the last thing is to give the graph a title. Luckily, the table name has a title as well, but we can just call it Jill's secondary math scores. So here's your steps for constructing a line graph. Again, if you have any trouble with that, feel free to just ask your teacher. For your homework, you'll answer some questions based on a line graph, and then you'll make your own.